Hi, my name is Pujan Dave and I'm one of the third-year residents at Wilmer. For my talk, I'll be discussing visual field variability. I have no disclosures. As we know, a cornerstone of following glaucoma patients is automated visual field testing. Unfortunately, visual field testing can be very variable, and this variability can make it difficult at times for clinicians to interpret the field tests. There are many causes of variability, patient factors such as cognition, glaucoma severity, etc., as well as reliability of the visual field tests themselves. For instance, if a patient had a bad test day, their field test may look very different from their prior tests. Our main question was, does early visual field variability predict future visual field progression? To help explore this, we analyzed two specific questions. First, does early visual field variability in the first 5 visual field tests predict the likelihood of future visual field progression or worsening? Second, does early visual field variability predict the likelihood of future rapid progression as defined by worsening of worse than -1 decibels per year? We hypothesized that patients with a lower initial visual field variability, meaning more consistent early tests, will show a higher rate of future visual field progression. We reviewed data from the Glaucoma Research Network, which is a large data set with nearly 1 million fields over a 20-year period from 6 different institutions. For our study, we had about 90,000 fields from 6,500 eyes, who each had at least 10 visual field tests per eye. A visual field was unreliable if, for mild to moderate disease, it had more than 15% false positives, more than 25% false negatives. If a patient had advanced loss, then more than 50% false negatives. An eye was labeled as less reliable if it had more than 5 unreliable fields. To answer our first question, we had a linear regression model. We ran one linear regression for the mean deviation of the first 5 visual fields per eye, and a second linear regression for all future visual fields per eye. These were used to calculate the rate of change, represented as the MD slope, of the visual field tests. We then took these variables into a separate linear regression model, in which the independent variable was the R-squared of the MD slope of the first 5 visual fields. The R-squared is the coefficient of determination, a measure of goodness of fit that quantifies the amount of variance. In other words, how much variance or variability is there in the first 5 visual field tests? The higher the R-squared value, the less variable. The dependent variable was the MD slope of all visual fields after the first 5. We adjusted for factors such as baseline disease severity, reliability, age, and MD slope of the first 5 visual fields. To answer our second question of whether early variability could predict future rapid progression, we had a logistic regression model in which the independent variable was the same, the R-squared value representing the variance of the first 5 field tests, but the dependent variable was now a yes or no question of whether there was rapid progression or not. And we adjusted for the same confounding variables. The mean age of our patients was around 63, with a mean deviation of around -5 on average. Most patients had mild disease followed by moderate, then severe. These were labeled by standard mean deviation cutoffs of -6, -6 to -12, and worse than -12. The patients had an average of around 13 visual fields total, with an average of about 9 years of follow-up. And the rate of field loss was low, comparable to other published data, around -0.3 decibels per year. This is a density plot which shows the distribution of R-squared values of the MD slope of the first 5 field tests, again, which represents the variance or variability in the first 5 field tests. The closer the R-squared is to 1, the less variability there is in the data. The mean R-squared value for our data is marked by this vertical dashed line at around 0.37, indicating high variability in the initial 5 fields on average. This is a scatter plot with a low S-curve. This shows the early variability as represented by the R-squared, again on this x-axis, and the MD slope of the future visual field tests, future meaning past the first 5. And we see as the R-squared value gets closer to 1, indicating less initial variability, there's a trend for the MD slope to be more negative, indicating a higher rate of field loss. In adjusted analyses, we found that less initial variability, as well as moderate glaucoma severity, were both associated with a higher rate or more negative rate of visual field loss. The effective age was small, though statistically significant. And if there was an improvement in the MD slope in the first 5 visual fields, there was a statistically lower rate of future loss. Of note, eye reliability did not predict future worsening. For our second question of whether variability is associated with future progression, here again, the early variability as described by the r-squared on the x-axis, but on the y-axis we now have the likelihood of rapid progression. And we see that as the r-squared value gets closer to 1, indicating less variability, there is a higher likelihood of future rapid progression. Finally, in adjusted analyses for this logistic regression, we found that lower initial variability and moderate glaucoma were associated with a higher likelihood of future rapid progression, with an odds ratio of over 3. The effective age was again small, and being a rapid progressor in the first 5 fields was a very strong predictor of future rapid progression. And finally, similar to before, eye reliability again did not predict future rapid progression. There were a few limitations to our study. Our findings may be specific to the 24-2 CETA standard testing algorithm, and our findings may be specific to the Humphrey visual field machine that was used for these fields. We didn't stratify by other factors that could impact eye reliability, such as cognition, because we didn't have access to these data. In conclusion, there's an association between less initial variability in the first 5 field tests and a negative linear trend in future visual field mean deviations, as well as future rapid progression on visual field testing. Finally, and perhaps most importantly, rapid progression on presentation, especially in the setting of low variability in those first 5 tests, must be watched very carefully and treated more aggressively, because these are eyes that in particular may be at much higher risk for progression or worsening. Thank you to everyone involved in this project, especially Dr. Yohannan. I'm happy to take any questions.